Hello everyone, this is Miss Rutuja Gade, final year BTech student in Civil Engineering from Anna Sahib Dange College of Engineering and Technology, Ashram. Today I am here to present one topic with you, that is the elastomeric base isolation system. Before directly jumping towards the elastomeric base isolation system, we will see what actually means the base isolation. So the base isolation, as the name indicates, the base is isolated. That such a system is provided to separate the substructure from the superstructure, and it provides the protection against the seismic waves or earthquake waves. And this system absorbs most of the seismic waves, and effect to the superstructure is getting reduced due to the seismic waves. Okay, so we'll start with the introduction. So elastomeric base isolation system. So the elastomeric base isolation system is a seismic protection technique widely used in civil engineering. It involves placing a layer of elastomeric material between the building's foundation and the ground to absorb seismic energy. Okay, the material is placed. Which material we will discuss about it later. Okay, this system helps reduce the impact of the earthquakes on structure and ensures their stability, as I said. Okay, next is the how elastomeric base isolation works. Okay, the elastomeric material is used in this system is made from the combination of rubber and other additives. It is designed to be flexible and deformable, allowing it to absorb and dissipate the seismic forces. That means the seismic energy intensity is getting dissipated. Okay, that means it's reduced the impact of the seismic waves in the upper layers and getting absorbed it at that base isolation system only. Okay, as an earthquake occurs, the elastomeric isolators elongate and compress, effectively reducing the transmission of energy to the building. Okay, next is the advantages of elastomeric base isolation system. So it provides the enhanced seismic protection for buildings, reduced structural damage and potential collapse during the earthquakes. Okay, allows for greater design flexibility as the system can be customized to suit various building types and sizes. That means this type of the system you can install in various types of the building. It is customized. Okay, you can change it according to your use, according to type of your building, according to your location. Okay, it provides a cost effective solution compared to the other seismic protection methods, as it requires less construction and maintenance. Okay, the cost effective solution, why we say that, because here we use the rubber as a major component and the cost of the rubber is not so much expensive. Okay, so this system is a cost effective system. Next is the types of elastomeric isolator. So these are the types. That is the laminated rubber bearings. This isolator consists of alternating layers of the rubber and steel plates, providing both flexibility and strength. Flexibility due to the rubber and strength due to the steel, of course. Lead rubber bearings. This isolator contains a lead core surrounded by rubber, allowing for increased energy dissipation and damping. Okay, then as you can see in this image also, there is a lead core, there is a rubber core. Okay, so lead is also a major component of this system. So high damping rubber bearings, these isolators are made from special type of the rubber with a high damping properties, providing superior seismic performance. Okay, next is the design. What are the design considerations during the base isolation system? Okay, the design process involves considering the factors such as the building's weight, height and expected seismic forces that can be generated according to that area or according to that location. Okay, the selection of appropriate elastomeric isolators based on the building's requirement is crucial for optimal performance. Okay, that which type of the material is you used, that is I already discussed about this are the some of the types. Okay, so from which type you getting adapted for your building, so their efficiencies also depends on this. Okay, the design should also consider the foundation stiffness and the overall structural response during an earthquake. Okay, next is installation of elastomeric base isolation system. So the installation process involves excavating the foundation, preparing the surface, and placing the elastomeric isolators. That much simple, okay? But the careful attention is given to ensure proper alignment and spacing of the isolators to distribute the load evenly. Here the role of the structural engineer is the primary importance, because their effectiveness, it depends on where it is going to be located. So proper load consideration has to be taken into consideration to know about its effectiveness, that where we can place this isolator so that it gives the maximum output, maximum effectiveness, okay? These isolators are then securely attached to the building superstructure and foundation to provide stability. That's all, okay? Next is performance and testing of elastomeric base isolation system. The performance of the system can be evaluated through the various tests, including the shake table testing and the computer simulations. Okay, this test help determine the system's response to different seismic forces and validates its effectiveness in protecting structure. Okay, why we conduct this test? To know how much effective is it. Okay, ongoing monitoring and maintenance are essential to ensure the long-term performance of the elastomeric base isolation system. Monitoring and maintenance, it is a prime importance of not only for this isolation system, but for all the isolation systems. Maintenance and monitoring is of the prime importance. Okay, case studies, okay, in the world where it is getting adapted. The first is the Transmerica Pyramid in San Francisco, California is a notable example where elastomeric base isolation was implemented successfully. Second is the Taipei 101 skyscraper in Taiwan also utilized this system to protect against earthquakes in a highly seismic region. Numerous other buildings worldwide have been retrofitted or designed with elastomeric base isolation to enhance their seismic resilience. You see, these are the most important structure from the world, but still they adapt this elastomeric base isolation system. Okay, why? Because its effectiveness. Okay. Next is considerations and limitations of elastomeric base isolation system. Some limitations are also there. Okay, the design and implementation of elastomeric base isolation requires careful consideration of factors such as soil type, building dynamics, and load building codes. As I already told about, the role of the structural design is prime importance here, so we have to take into consideration about the loads and how much load is getting transported to the superstructure. Okay, the system may have limitation in terms of maximum allowable displacement, load capacity, and response time also. Regular maintenance and inspection are necessary to ensure the system's continued effectiveness and identify any potential issues. Okay, next is we'll end with the conclusion. So the conclusion is that the elastomeric base isolation is a proven and the effective seismic protection technique for enhancing the resilience of the structure. Why I say it is proven? Because as I said, the examples from the world, they adapt that system, because these structures are the most important structures from the world point of view. Still they adapt this system. Why? Because of effectiveness. It offers numerous advantages, including improved seismic performance, design, flexibility, and cost effectiveness. Okay, with a proper design, installation, and maintenance, elastomeric base isolation can significantly reduce the impact of earthquake on buildings and ensures their safety. So that's all about for elastomeric base isolation system. That's all from my side. Thank you so much.